Okay. Thanks, Ron. Oh, noisy. Right. Last lesson we did modulus function. Yeah. Let's see what's next. I think you might have to close the windows, Juan. It's very loud out there.
Oh?
Yeah. Unfortunately, I think so. I don't think it's that warm, is it? If it gets warm, we'll open the door. How's that?
Okay.
There you go.
He sent you an email.
Did he? I don't know. Should I believe him? Where are we? Here. We did this. Okay. Next lesson actually is I didn't say that okay, but it's okay. It's nice enough. We're going to go back to integration. Now you're right, Yusuf, it is pretty easy. Right, so let's have a look here. Can you write this down? This is integration part 2, the return of the integration. By substitution is the name of the method. Yes. What happened, Fuan?
Really?
What happened?
What is raining?
Why are you late?
Everybody wants to sleep.
A lot of things. I think you're
No, no,
tired.
you won't.
You know the weather is so good, so
Because
lovely.
yesterday
I woke up to 5.
stressed.
Yeah.
I'm tired.
Yes. Me too. Right, so as I was saying, this method's not so difficult. Let me explain. We know how to integrate something like x squared. And we know how to integrate something like ex. So then if I said let's integrate something like ex squared, we don't know how to do it. Because just like with the product rule and the quotient rule, it's not as simple as you think. But we do have a method called substitution, which works quite well for a lot of problems. So let's have a look at some simple examples. Let's say I have something like sine 4x dx. Do we know how to integrate sine? We do. Do we know how to integrate 4x? We do. So what we do is we let u equal to the inside piece, 4x. Yes?
Do you have the pencil lead?
Pencil lead, I have nothing but this. You're out of pencil?
Oh, by what?
Oh well. You'll just have to borrow a pencil from...
I think it's variable.
Well, you'll just have to make do.
Look, is this method? This method? Oh.
No.
Okay. Now that that pencil catastrophe is over, we'll continue. As I was saying, you let u equal to 4x. And then you calculate du dx, which is 4. So then dx equals du over 4, because you can actually rearrange this. If I put that in here, I can change this into sine 4x du over 4. And also, if I put that in as well, I get sine u du over 4. And remember, I can take the 4 out. Remember I was telling you about this before. So what we've done is we've changed the problem into an easier problem. Sine u du. What's integration of sine? So you finish by putting back in du. And that's it. I'll do some more difficult examples, of course, but this is the basic idea. Have you seen this before, Yusuf?
No.
Really?
Yeah.
Oh, because you didn't study
Yeah.
calculus before, yeah. Juan,
Hmm?
have you seen this method before? You have?
Study calculus, but
Not like this.
not the examples. This is examples.
Have you seen this before, Lee?
Mm.
This is new?
Mm.
For Lee?
Mm.
Wow. Flan?
I even not finished high school.
So you haven't seen this? Okay, let's have a look at another example when you're ready.
Where is minus?
Because sine integrates minus cos.
Sine becomes minus cos when you integrate it.
Oh.
Continue? You have that? Okay, let's try one a little bit harder. So let's say you want to integrate the one I had a moment ago, ex squared dx. What do you think you could make u equal to here?
Ax squared.
Dx squared, yeah, very good. So what does du dx equal? 2x. So what does dx equal? Du over 2x. So that can go in?
Du.
Oh, thank you. What on earth did I just write? Oh my goodness. Totally not with it. Dx equals du over 2x. That can go in, and that can go in, and this becomes x squared du over 2x, and then replacing this as well, that's x du over 2x. But what's nice here is that this cancels with this, so you're left with a half eu du, which is just a half eu, which is then a half ex squared plus c. Is that okay, Juan? You look confused. Is that okay, Lee?
Where is the last line? Why the du eliminated?
What's the integration of EU?
EU.
EU. Ah, okay.
Yes?
Where's everyone?
Can you invite so? He's at the embassy. Yahya? I don't know. Andrew?
Andrew.
I don't know. Omar?
Sleeping.
How does he know?
Huh?
He lives with them and he doesn't know where Andrew is.
A different room.
So? What's the matter? Okay. Can I scroll down for another one? Yeah. Okay, let's see. Let's do something like this one. Well, this actually is one you already kind of know the answer to, but I want to do it anyways. U equals 2x plus 1. du dx equals 2. So dx is du over 2. So that goes in. And that goes in. And this becomes 1 over u du over 2. Which is a half 1 over u du. And what does 1 over u become when you integrate?
U squared? Oh, you got 1. 1 over u.
You meant to say like you, didn't you?
Okay.
Yeah.
Great.
Which
Two
is
minus 2 over
1.
Integration. No.
2. Ah, that's
Yes.
log u.
Yeah, man, we're done.
Oh, I didn't
I'm
get it.
sleeping.
Wake up, please. Do you have that written down, Yusuf? And it's okay? Are we getting the idea for these? Lee, did you write anything down? So simple. Why bother? Why bother? Right. I'll give you one to try. See what you get here.
Is that x squared plus 1?
It is. Well, Yahya and Andrew, I'm going to fulfill my promise. Come back at the next class. Too late. How are we doing? Did we get it?
Yeah.
Okay, I'm waiting. President? What's this? I can't see. X squared? Yes, looks okay. Okay, do you have an answer, Yusuf?
Yes, just see.
Okay. Wrong? No, it's not.
No?
It is not. What the heck is this? Is that a log?
Yes.
I can't make it out. It could be right. Let's have a look at it. So here we let u equal x squared plus 1. So that means du dx equals 2x. So that means dx equals du over 2x. So far so good? So this integrates to x over u du over 2x. Cancel, cancel, take that out. So what happens when you integrate 1 over u du? Well, that becomes 1 over 2 log u. So the final answer is 1 over 2 log x squared plus 1 plus c. Yeah, it's okay? Alright. Shall we make it a bit harder? Let's see. Okay. Try this one. Whoa! It's okay. Everything is okay.
How to do why that code?
Maths.
No.
What part?
The power 10 to
10 to the power. To the power of 10.
no that
Binomial?
Binomial expansion.
Yeah. Brackets?
no. Like for example, what is that of x squared?
Integration?
Yeah.
Yeah, integration of x squared is x cubed over 3 plus c. I'm so tired. how I'm going to get through this day. I don't know. Well, it's helping Faisal isn't here. It's helping. Get an answer, Juan? You did. What did you get?
You can, yeah, you can compare that.
Interesting approach. You said you get an answer?
2x plus 3 divided by 11 over 22.
Yes.
22?
Yeah.
22.
Yeah. Why is everyone shocked at Yusuf? Let's have a look. You're all going to look so silly when Yusuf gets the right answer. Right, Yusuf? Okay, so u equals 2x plus 3. du dx equals 2. So dx equals du over 2. So this becomes integrate u tan du over 2.
Yeah.
And then that becomes u11 over 11 1 over 2.
Let's see.
Yeah.
Plus c, of course, yeah. So this is 2x plus 3 power 11 over 22, which is what he said.
22? Yes.
Yeah, see how they're like, yeah, 22. I knew that. Why were you surprised?
Oh, I thought he said the power of 22.
No, I don't believe you. No.
Integrity.
No. Give Yusuf a break, alright? Okay, this is okay, Yusuf?
Yeah.
Yes. You need to write this down, Juan? Yeah. Okay. Continue? Yeah? Alright, let me give you one more here, which I'll do. Integrate one plus x over 1 minus x dx. Whoops. Okay, ready? You have an answer, Yusuf? Do you want to share it with the class, or you don't want to?
Oh, sorry.
Let's have a look. So, what do we let u equal to?
1 minus x.
Yeah. So then, du over dx equals minus 1. So that means dx equals du over minus 1. Or in other words, minus du. So this becomes 1 plus x over u minus du. Now there is a small problem here. What's this problem with this? Oh no, there is a problem. This is integrating u, but here we have x. We shouldn't have this here. We need to have only u. How can we fix it? By going back here. We can see that x is equal to u plus, x is equal to 1 minus u. So I can change this now into minus integrate 1 minus u over u du, which equals minus integrate 1 over u minus u over u du. Huh?
Minus the 1 beside the x.
Thank you. So it's 1 plus this. So that's 2. So that becomes integrate minus 2 over u plus 1 du, when I put the minus in. Which is not so bad. This integrates to minus 2 log u plus c, or in other words, minus 2 log 1 minus x plus 1 minus x plus c. Did you get that? No. So this is a harder one.
Why do I make u equal 1 plus x instead of 1 minus x?
You will turn the problem into a harder problem. No, that's not true. You will turn the problem into a problem of the same difficulty. So you've gotten nowhere. You know what I mean? The reason you make the choice for the u is to simplify it. By choosing 1 plus x, the problem doesn't become any easier. Did you choose 1 plus x? So you want to write this one down.
Now I have a different way to eat apple.
What?
Eat all the apple.
You eat all the apple?
Yeah, eat all of it.
Some people do that.
Oh, cool.
I think that's strange.
I make 1 plus x equal to
I don't know what you're asking me. But Wong already asked me this.
Huh?
Lee also made u equal 1 plus x.
But you still can go to where you do that.
You what?
So you can still find the same answer. You see.
Not really. Because you haven't made it any simpler. You know what I mean? You probably ended up with something like u over, I don't know, 2 minus u or something like this. This isn't, what the heck is this? This isn't any way easier, you know? No. It just, it doesn't help. Yeah.
How can you make the bottom is your above?
You might be thinking of a different lesson which we'll do later in the chapter, where you make the bottom equal 0.
Make bottom
No,
equal
you, how do you know which one to choose?
How do I know?
yeah.
Magic. There is no easy way to know, and in the exam, they sometimes tell you in the question what to use in the exam. But I'll give you some basic rules, ideas, okay? So, usually you let u equal to what's on the inside. So if you had like an ex squared, you let u equal to x squared. And you usually let u equal to the bottom if you had like a fraction. Is it always this? No. In some cases, which we'll do later in this chapter, it's not like this. But for today, it's going to be one of these. Yeah? Okay. What was I going to say? I'm tired, I don't know what's going on. This is math class, isn't it? Great. What we'll do... Ooh, food. What you got? Crisps at 9:45?
Why not? I don't have breakfast.
I was told in China the food for breakfast is not really different than the food for supper. Yeah? It's not like you have special breakfast food and special supper food. It's the same food. Is that right?
No.
No, food different.
Oh, it's still different, yeah?
Yeah.
You have food for breakfast that's different to supper?
Yeah.
Ah, okay. Because there were 2 Chinese girls in the canteen yesterday at like 9 o'clock, and they said, we'll have a plate of chips.
What?
And he said, chips for breakfast? Yes. Why not? So I'm like, chips for breakfast?
It depends, actually.
Yeah.
Depends. You would have chips for breakfast?
It's like the main food in China is rice and noodles.
You would have rice and noodles for breakfast?
Normally if you have noodles, yeah, it's normal.
Is it? You have special breakfast food.
Yeah, but not rice.
Yeah, not rice.
If I eat rice
Not
for
noodles.
breakfast, what am I gonna eat for lunch? Noodles.
And then for supper? Rice and noodles.
Yeah. Why not?
Rice noodles.
Yeah. Okay. What we'll do, I think it's a pretty easy lesson for this first lesson of the new chapter. Oh, good news. My server should be working now.
Yeah, it's work.
How did you know already?
I opened today.
Oh, good, because I only fixed it this morning.
Yeah.
Like at 7 o'clock. I was trying to fix it last night.
Where is my bag?
Yours and yours is right here, and I'm eating it.
By the way,
And
you
this is my first one.
still what can I get in the lab book?
I have nothing.
Soon, my friend.
Thank you.
You want one?
Oh.
Pass it over to that guy.
Thank you, you are the best.
Okay. Can you see? No, not really.
You just speak it this morning?
Did I what?
Speak this morning?
Yeah. At 6:45.
I opened it at 8 o'clock.
I tried fixing it last night, but I couldn't get it to work.
What we're supposed to do this?
I would want you to practice some of these, but I'm not worried about the time because it's such an easy lesson. And my worry is, if I'm still waiting for those other so-and-sos who are late. If I start the next lesson now, then they're going to miss that. Even though they're not here, they're still giving me trouble. It's their special ability.